Welcome to Excel 2010 Statistics video number 29. Hey, if you want to download this workbook, Excel 2010 Statistics Chapter 3, click on the link below the video. In this video, we got to talk about weighted mean, mean from group data, geometric mean, and trimmed mean. Now, weighted mean. Sometimes you have all of the data points, and sometimes you don't. Sometimes instead of listing, so we have 26 4 times over here, something like that. I can't really see. Oh, there it is. So there's 4 times. So sometimes instead of listing all the values, it's listed this way: each individual value and how many times it's listed. So to get the total, we still have to calculate our mean, add them all up, divide by the count. So we're going to have to add an extra column and multiply this times this, 4 times this, 2 times this, and then add up all the weights, because that tells you how many there are, and then divide the total by the count. So we'll create a formula. Relative cell reference is this one times this. So it's the actual value times the weight. And then we add them all up. Alt equals 487. And now we have to add up all the weights. Alt equals. And now we can calculate the total. Add them all up. Divide by the count. Now, an alternative to this, if you don't want to add extra columns, we can use the sum product function. Now, I want you to notice something. Here's a column, and here's a column. And this formula multiplies the first 2 items in the column, the second 2 items in the column, third, fourth, fifth, sixth. It's as if we're multiplying 2 columns all the way to the last one, right? And then what are we doing with the multiplied columns? We're adding them. Well, guess what? There's a function that skips over adding a whole extra column like this called sum product. Now, sum product specifically is designed to take 2 columns, multiply them, and then adding. So this is what it'll do. Sum product will take all those values, multiply them all in a single formula, and then add them all up, and this will be our answer. All right? So equals sum product. And it says array 1, array 2. You simply list the 2 columns that you want to multiply and then add in succession. And they have to be the same dimension, meaning this is 1 column by however many rows. And that will add, right? So that's kind of cool, right? That avoided this whole extra column. Now, the problem is if we want our weighted mean, we have to divide by the sum of all these. But no problem. We can take this formula and say divide by the sum. So this kind of formula right here, which is hard to see, I have messed up formatting here. Let me. So there's a little bit easier. That formula requires that you just have the actual values and the weight, so you don't have to do any of this other stuff here. Now, just to show you, this, of course, has to equal the average from the original data. So you could prove that to yourself here. Now, oftentimes, like when doing cost accounting and get your weighted average, you do not have all of the actual values. But if you did, you'd, of course, get the same value. Oftentimes in accounting, you'll have the cost for a particular item that you bought on that invoice and 100, and the cost at another particular price and 50, or however many you bought. And so that would be a great example of weighted mean. But that's how you do weighted mean. Now let's go over to the sheet, estimated mean group data. We've already seen how to do this quite often. We have a data set, and it already came grouped. So here's our categories, age, and here's our frequency. Now, you can calculate an average from group data, but it's only an estimate. Because what happens here? You have 0 to 19, 20 to 39, and you may have the lower and upper, but you actually don't have the individual values. So the way to estimate it from a frequency distribution like this is to calculate the midpoint, right? Because there's 13 that are between 0 and 19. So if we took 13 times the midpoint, it would at least give us a rough estimate of all it would give us a rough estimate of the total from this particular category, meaning all the ages in this category added up. So the trick is the midpoint, and you have to take lower. It's lower plus upper divided by 2, which is the count. So I'm going to use the average function. All right, so those are the midpoints. Now we have midpoints times all of these right here. And that gives us the total. And then we divide by the count. I'm going to use that same formula we just used a moment ago, sum product. So I'm going to say that column times that column right there. And then divide by the count. Oh, the count, it's the frequency, right? So divide by and this. Now, this is because we have our frequency distribution, and we actually had to calculate our midpoints here off to the side. And there we have it, 38. So averaged age from grouped data, and it almost always will be different than the actual average. It is an estimate when all you have is a frequency distribution. All right, let's go over to GeoMean. GeoMean. Geometric mean. Now, the geometric mean is something you usually learn in a finance class. This actually isn't in our textbook, but we're talking about means and averages, so this is a good time to talk about them. It's good when you have percentage change. And this could be up or down. These ones happen to be all up. But anytime you have a number less than 1, or it could be, you could have 100% change too. But so we want to average these. Now, most people just use the mean or the average function. And in fact, in a lot of finance that are looking at stock values and things like that, bond value changes and all that kind of stuff, they actually do use the mean or average function. As we'll see, we're going to do both here. The GeoMean is more conservative. It actually gives you the true average compounding rate. So it's a type of average when you have percentage changes. Now the trick is, and you can see one formula we're going to use here. It's actually this one. You have to multiply all the percentage changes and then take the nth root. So if there's 10 of them, you take the 10th root and then you subtract 1. But the particular x that you use has to be 1 plus the percentage change. Now, it could be it could be not an increase, but a decrease. These are all increases here. All right, so you ready? 1 plus that. That gives us the x value to then multiply together. Right? So we get all of our 1 plus the percentage change. Now, in order to calculate this formula, right, we need to know how many, and then take that nth root and then subtract 1 to actually get the percentage change. So I'm going to count. I'm using count because I'm counting numbers. Now the formula. We have the GeoMean, and we're going to see two formulas here, geometric mean 1, geometric mean 2. But it is, and I didn't do that correctly. The first one is multiply all of our 1 plus the changes, and then we have to caret. And there's no 10th root function in Excel, so we have to remember algebra. If we raise a particular number to 1 divided by some number, that is the same as taking the nth root. Right? So this is going to be an exponent that's also division. All right, so you ready? I'm going to use the product function. Product can multiply. So the product function. Multiply all these. That's the first step. So if you look down here, we just got to multiply. Now we have to take the nth root. So caret 1 divided by 9. Now, this will give you 1 plus the average percentage change. And we can see that if we enter it in, it's 1.13333. So simply have to subtract 1. And that gives you the geometric mean. This is the actual average compounding rate over these periods here. All right, now let's learn about the GeoMean function. So there's a GeoMean function. Oh, you mean I didn't have to go through all that? Yeah, you didn't have to go all through that. But guess what? You still have to have your 1 plus the percentage change. Now, when I enter this, this will give me 1 plus the average compounding rate. And so I subtract 1. So we just want to be aware that there are other types of averages. And if you want the real compounding rate when you take a finance class, you'll have to do lots of compounding. That's how you calculate it. Now let's calculate our average. And the average will always be larger. And so oftentimes in finance, you will take just the average of the percentage changes. And it will always be greater unless they're all the same value here. Right? So the way it works is if you want to be conservative in your estimates, you can use the GEOMEAN. If you want to be less conservative, you use the average. Now, that's the first formula. The second geometric formula is related but slightly different. This formula can be used when you know the beginning amount and ending amount and the number of periods. So this is whole food stock price in 92 and in 2005. And what I'd like is I'd like the average compounding rate per period. All right? So first, I need to calculate the periods. So here, I have a slightly different situation. I'm not counting values. I'm subtracting this minus this. So the year 2005 minus the year 1992. So 13 periods. Now, this method, we obviously can't use this method over here. So the way you do it is you take n divided by beginning and raise it to the 1 divided by n, and then subtract 1. So I'm going to say equals the end amount divided by the begin amount. Now, the order of operations in Excel come into play here, because if I exponent, exponent happens before division. So I actually have to put this division in parentheses. I'm forcing that division to happen first, caret, and then also I want to force this division to happen first too. So 1 divided by 13. Now, if I enter this, it'll give me 1.27. And I want the actual rate, so I subtract 1. And that was if we only knew back in 1992 to invest in Whole Foods in 2005. Actually, in 2005, prices come considerably down. Now, here's the cool thing. The reason that GEOMEAN is so cool is because now we actually do have the compounding, the rate per year that we can use to go from the begin value to the end value. So in a finance class, you would take whatever the begin number is, and this works if you put money in a bank, say for instance, and you would multiply it by 1 plus the actual geometric mean or the compounding rate, and then raise that. This is saying multiply the original amount times 1. That gets the principal amount plus the average change. And you have to caret that to 13, raised to the 13th power, and boom, there it is. So that's kind of a proof that we calculated this rate right here. Well, if it's correct, if it's the true geometric mean or average compounding rate over all these years, if we use it in our future value calculation, we better get the ending amount, and we do. And finally, let's go to the trimmed mean. Sometimes we talked about when there's some very large or small values, you use median, right? Median is a great value to use. But if you sometimes, and the book mentions this, you can trim your values. So you remove the 5% of the smallest and largest values from a data set, then calculate the mean. So first, let's calculate the count. So there's 37. Values to drop, I'm simply going to multiply this. 5% times this. And that'll give me an approximate number to take off the top and bottom. So I'm going to round this up to the integer. You could just write 2, or you could use the round function. Now, actually, we could probably use the round. Why don't we use round up? Round up will round up to the next integer, or round to whatever position we tell it to. This number of digits right here, if we put a 0, it says please round up to the next integer. And so it's 2. So our trimmed mean, doing it the cheap and dirty way, equals average. I don't want those two. These are sorted, so I'm going to highlight the ones in the middle and skip the 2 at the bottom and the 2 at the top. And so that would be your trimmed mean. All right, so trimmed mean, geometric mean, an estimate for mean when you have group data, and weighted mean. All right, we'll see you next video.